All right, in problem one, we got a particle that's moving along the x-axis so that its velocity is given by this whole thing. And at time t equals 0, the initial position of the particle is x equals 7. And for part A, we have to find the acceleration of the particle at time t equals 5.1. Okay, so the main thing you have to recognize is that acceleration is the derivative of velocity. And so for this, you just have to evaluate the derivative of velocity at 5.1. Now, since we get a calculator for this problem, you know, this is not even going to be an issue. This will be simple to do. We just go to our calculator screen, which is not that one, which is this one. Go to menu, use our calculus function, numerical derivative at a point. Variable x, let's set the point at 5.1, first derivative. And we just plug this expression in for our function. So we got x to the 6 minus 13x to the 4th plus 12 divided by 10x to the 3rd plus 3. Always double check to make sure you didn't make a simple mistake or when you enter this in, the syntax error, because that could eat valuable minutes from your testing time. And bang, there we go. That's our answer. So let's just write that. A of 5.1 is equal to V prime of 5.1, which is about equal to 6.4918159423. All right, part B. Find all the values of t in the interval 0 to 2 for which the speed of the particle is 1. Okay, so let's remember that speed is equal to the absolute value of velocity, because remember, velocity in physics can be positive or negative, because velocity also tells you the direction. Speed doesn't tell you direction. Speed just tells you magnitude. So we just want to find when is the absolute value of velocity equal to 1. For this, it'd be best if we graph the velocity function and just look for when it's equal to 1 on the graph. So we go to our calculator, go to our graphing screen, and I believe, I already have it in here. I'm not going to worry about entering it again. But here, we have to analyze, see where it's equal to 1. So what we want to do is go to menu and go to our trace function. Having trouble handling this trace. Graph trace. And you can just scroll along your graph like that. I think my trace step is kind of big. TM looks like, well, So let me go back to that function. When you go to trace, you're going to see this option for trace step. So for this, it tells you how much to go by, how much each x will change by. And depending on what you're graphing, you got to just, think about what would make sense. For this, I'm just going to go by 0.1 because I think that'll be best. So see, I'm at 0.6 right now. So every time I click to the right, it'll go up by 1 point. It'll go up by 0.1 to the 0.7, the 0.8. It looks like it's between 0.8 and 0.7. And it looks. Let me change the trace step even smaller. Let me go by 0.01 to be more precise. So I want to move it up until I get to 1 on this. Oh, so this is about 0.77. So we have one value when x is about 0.77, or in this case t. And over here, we can see we have another value. So I wonder if we can. No, let me see if I can. Oh yeah, duh. Let me do my pointer. So let me like be quicker. Probably should have done that first. Calculator does not like me. Okay, and let me go back to trace again. Sorry for the technical difficulties. I'm still over here. Let me just, well, you're gonna find if I click this a lot. Actually, I just remembered, I'm an idiot. That actually kind of saved me. We only care about the interval from 1 to 2, or from 0 to 2. And we also want to see, and at this case, v of t is 1, but let's look at the point when v of t is -1. So I'm going to move this, see how it's like -1 at about 1.4. Moving a little farther away. So about 1.4, it's -1. So the closest one will be 1.4 will be fine. So t will be 1.4-ish. And that's when v of t is -1. So these are the two answers here. All right, let's look at C now. Okay, so find the position of the particle at time t equals 4, and is the particle moving away from the origin, or is it moving towards the origin, away, or away from the origin at this time equals 4? Explain, justify. Okay, so let's first find the position. So we want to find S of 4. One way to do this is to set up an integral, the integral from 0 to 4 of v of t dt. Because remember, the antiderivative of v of t will be s of t. And so when you were solving this, we'll get s of 4 minus s of 0. We know what s of 0 is because that's the initial position, which is 7. Let's go to this next line. So we get s of 4 minus 7 is equal to the integral from 0 to 4 v of t dt. So I can just first integrate this with my calculator and add 7 to it, and that'll give me s of 4. So s of 4 equals 7 plus whatever this integral is. Let's pop to our calculator. Let's go to the numerical integral from 0 to 4. And again, always pay attention to when you're entering this. There's nothing worse than messing up and having to type in the whole thing again, because it's going to eat valuable minutes from your testing time. Okay, so I believe that is, no, actually, we'll see. that minus sign doesn't look right. Let me check if that is a minus. Delete. Yeah, that looks better. Okay. And we get negative 0.28 for that, about. And let's add 7 to it. So this is going to be about plus 0.28, or plus a negative 0.28844, so forth. And we'll get, when you add 7 to this, to be about 6.74. So S of 4 is about 6, not 6.74, 6.711, 11558. Now, is the particle moving away from the origin or toward it at this time? Well, you want to think about the velocity in relation to the position. So for example, the origin, let's 0, 0. At this point, let's say it's at 6.7, right? Now, since velocity has direction and magnitude, if velocity is positive at this point, it's moving to the right. Then that means it's moving away. But if the velocity is negative, right, positive, if velocity is negative, it's moving towards the origin. Now, the reason for this is because if this position was negative, let's say a negative 6.7, then it'd be the opposite. If velocity was positive, it would be moving to the origin. And if velocity was negative, it'd be moving away from the origin. So you have to make sure you address both. They both have to, go with each other. So V of 4, we want to find V of 4, and we can just look at our graph. So going back to our graph, you can clearly see that V of 4 is positive. That's 3.56. The V of 4 is positive, and all he cares is about the sign. So V of 4 is greater than 0. So that means we're in this situation. So since the position and velocity are both positive, at this time, the particle is moving away from the origin. All right, so one more part to go. Let me get some hydration in. Okay, so part D, during the time interval 0 to 4, does the particle return to its initial position? And give a reason for your answer. Okay, so we essentially want to see if during this time period, does V of t, like is V of t ever back to 7 on, again, on the open interval 0, or not including 0, but from 0 to 4. Does it ever equal 7 again? No, this is wrong. Does S of t equal 7 ever again? No, this is kind of this is basically some analysis and a real test if you understand how the intermediate value theorem applies to this calculus problem. So let's look at this. At S of 4, when t is 4, the position is 6.7. So if we can find on any time between 0 and 4 where the position is greater than this or greater than 7, like if it's 8, 9, if we can show it that S of t is more than 7 anytime between 0 and 4, then it's going to have to pass back to 7 because at 4 it's 7, it's 6.7. So for example, let me just draw a visual picture so you get the idea. So it's at time 0. Let's say this is the I don't know why I drew this axis really thick. It's not what I do. And the pencil just cracked. That's okay. So this vertical axis represents position. This is time. So at time t equals 0, our position is 7. And at time t equals 4, our position is 6.7. So since this function is continuous, I said 6.7, but I wrote 7. That was interesting. Then for this point to connect to this point, for it to get back, we can do this. That's one way. But if we can show that it climbs up at any point, it has to then go back down to get to here, which means it has to pass through the line, 7. Let's just say s equals 7. It has to pass through this point, through some value of s of t being 7. It has to pass through 7 again if it climbs above 7 at any time between 0 and 4. So that's what the intermediate value theorem is going to be applied here. So what we can show is that, and this is where you can analyze the graph. And again, you really have to think about this. This is a really good one to test your physics understanding as well. But you can see since the velocity is positive from 0 to 1, then that means the position is increasing. The position is getting larger. I mean, the position is, it starts at 7, but from 0 to 1, it increases. So if you integrate from 0 to 1 v of t dt, and then add 7 to this, this will give you the position at s of 1. This will give you the position at t equals 1. And we know it's going to be more than 7 because the velocity is increasing, because the velocity is positive up to 1. So if we integrate, and let's integrate the velocity function from 0 to 1. Make sure I don't mess up here. So and we get, what did I do? That's not correct. I must have messed up. Oh, no, that's correct. This plus 7, 9.4. So 9.4 is the position at s of 1. So that means at 1, this value gets to 9.4. So 9.4. So it climbs up to 9.4. Then to get back to 6.7, it has to pass through the line s equals 7. It has to pass through that. So there's some point of time between 0 and 4 where the position again is 7. It's the initial position. Now I did all this just to give you a visual. I think pictures are helpful for this. But when I wrote my answer, I'm going to show you my formal answer, how I wrote it. And then you can copy that down, but make sure you really understand this because this is a pretty tough problem. I think this is the lowest scoring on this exam actually. So don't feel like, this is probably the hardest one. This is the hardest one definitely on this exam and on many of the exams I've seen. But this is the answer I wrote for that problem. So feel free to write that or use that as your explanation. Yeah, the average score on this one was like 3 out of 9. I just checked. But there you go. I hope that helps. So feel free to give me any questions or leave any questions, comments, feedback, and I'll do my best to get back to you. So good luck.